So we've got the integral from 0 to 1 of 1 over x squared plus 1 all squared with respect to x. Now, the easiest way to approach this is to just do a trig sub using tangent. Because we have a plus here, and it's not a subtraction symbol, we know that it's tangent. So we can say x equals a, and a in this case is just 1 because a squared is 1. So we'll leave nothing there to represent 1. Tangent theta. And of course, the derivative of x in this case would then just be secant squared theta d theta. And so we can rewrite this as the integral, and the first thing we need to do is actually change our bounds. So when x equals 0, 1, 0 and 1 that represents, then we can say theta equals, and we start with, so when x is 0, we solve for theta. So what we would do here is we would say theta equals tangent, arctan rather, x. And so when that is 0, theta is also 0. And then when it is 1, theta is pi over 4. And so we can write that here, 0, pi over 4. And so that's our new bounds, from 0 to pi over 4, because what we've done is we've set x, and we have decided what our bounds with respect to theta will be once we plug in the existing values of x into our new version of x. So with these bounds, now we can go ahead and plug in the rest. We'll substitute secant squared theta for dx. So we'll write secant squared theta, and then d theta off on the side here, over, we'll do x squared, which is tangent squared, theta, plus 1, all squared. And then we can go ahead and rewrite this, 0 to pi over 4 of secant squared theta, all over. Now, inside here, that just simplifies to secant squared theta, and it's squared once more, so it's secant to the 4th power theta, d theta. That, of course, simplifies to 1 over secant squared theta, and 1 over secant squared theta is obviously just 1 over cosine squared theta, which simplifies to cosine squared theta. So what we've got really is from 0 to pi over 4 cosine squared theta d theta. And because we have a squared there, we're not ready to fully integrate just yet. Instead, we have to do a brief trigonometric step down. Sorry, that's a 4, not a 2. Pi over 4. And what that looks like for cosine is 1 plus cosine 2 theta all over 2 d theta. We can kick that 2 out front and just say 1/2 the integral from 0 to pi over 4 from 1 plus cosine 2 theta d theta. And now this is something that we can integrate. So we can just say 1 over 2 times the integral of 1 with respect to theta is theta plus sine 2 theta over 2 from the bounds of 0 to pi over 4. And now we're ready to go ahead and solve this. Because this is a definite integral and it has existing bounds from pi over 4 and 0, we don't need to use a triangle here. Which is a very basic trig sub thing when you are dealing with an indefinite integral. We usually have to draw a triangle, we have to solve for one of the sides, and then using that we can determine what theta is in each of these instances. But because we're using bounds, and we've converted our bounds from x to theta, we can now just directly plug in these bounds into the values for theta and get our results. So what we're dealing with is 1/2 pi over 4 plus sine 2 times pi over 4 is just pi over 2 minus 0, because we're plugging in 0 here for theta, plus sine, and when you multiply 2 theta times 0, that's just 0 over 2. Now, of course, sine of 0 is 0, 0 is 0. Sine of pi over 2 is 1, so that's 1/2. And what we're left with is 1/2 times pi over 4 plus 1/2, which simplifies to pi over 8 plus 1/4. And that's the result of this particular trig sub integral. If you have any other questions, or if you have any calculus problems that you'd like me to work on, please let me know in the comments and I'll be sure to get around to it.